In this video, we have a very basic integral problem. The integral of 1 over 3x minus 1 minus 1 over 3x plus 1 dx. Now this is an easy U-substitution. You can also use a basic formula that would apply whenever you have a linear expression in the denominator and a constant in the numerator. So no x or x squared, just a number. And this formula works great. Several formulas here. This one I actually did a video on this, but it's real straightforward. I derived several of these. So let's derive it here. That's another example for this video. So if we want to show that if you have any integral in the form a constant over a linear factor, you don't want a square here, has to be this form, binomial. A and B here are constants. K is a constant. So this will be pretty straightforward. We do U-substitution, that U equal to AX plus B. Then du would equal to the derivative on the right side. That's just A to be A dx. And divide through by A to isolate the dx. And then we come back over here then and say, okay, this is going to equal to, we want to show the result here. This is going to be the integral in K's constant, so I can bring it outside. And dx here is du over A. So I'll put the du here inside the integral. So du over A, and again to bring the 1 over A outside. So I'll make this K over A. And the denominator is U. So now we have constant K over A, integral of du over U. And of course this is just your formula for natural log of absolute U. So this would be A, and it's natural log of absolute U, but in our case, U is AX plus B, and then it's plus the constant of integration. So we got answer then is K over A. Anything in this form here can be given by K over A, natural log of absolute AX plus B plus the constant. And that derives this formula. And all of these formulas can be derived. Some will involve a trig substitution, maybe integration by parts, trig identities, and so forth. Anyway, that's the one we're going to use here. We could just go ahead and solve this problem using a U-substitution. Do one at a time here and let U equal 3x minus 1. And then for the second integral of minus 1 over 3x plus 1, let U equal to 3x plus 1. Over here, 3x minus 1. But we can use the formula now. Once you derive it, or your instructor gives you access to it, we can go ahead and write this up. So let's treat this as one integral. I can rewrite it as 2, but I'm telling you what I'm doing. So it's in this form. This is your K right here. 1 is the K. A is 3. You got the B there, minus 1. So it tells me then that it's going to be whatever the constant is. In our case, the constant is 3. So it's K over 3 times the natural log of the absolute value of what's in the denominator, 3x minus 1. And then it's minus, now we do the same thing. Treat this as another integral. Again, the K is 1. If this were 2, there'd be 2 over the 3. So A is 3 here, K is 1 again, so it's 1 over 3. And it's natural log of absolute, whatever is in the denominator, in this case it's 3x plus 1. And then it's plus your constant of integration. And that's one form of the answer. Maybe you want to put it in more simplified form here so we can use some properties of logs and factor out the 1/3 here. Got 1/3. And then factor out the 1/3, and then you have the natural log of 3x minus 1. Natural log of absolute 3x minus 1 minus the natural log of absolute 3x plus 1. So we factor out the 1/3, and then we have a difference of logs. Anytime you have a difference of logs, you can write the expression as a single log. Or this will be in the numerator, the first expression here, and the 3x plus 1 will be in the denominator. So it'll be like 3x minus 1 over 3x plus 1 plus the constant of integration. And that's your solution for this one. Again, 1/3 natural log of an absolute value of 3x minus 1 over 3x plus 1 plus the constant of integration. Thanks for watching. We'll see you next time.